Good day everyone, and welcome to another Atari 2600 project. My name is Steve, and today I want to take a look at this game. This is Indy 500, and it comes to us from 1978, made by the Atari Corporation. Wow, that's a long time ago. Why I'm interested in this game, though, is because it requires a driving controller. I don't have a driving controller, but going with the theme of this channel, I thought I'd build one. Now, the driving controller was packaged in the same box as Indy 500. If you bought the game, you got a pair of driving controllers to go along with it. But unfortunately, Atari didn't release any other titles that leveraged the driving controller for the Atari 2600. But what about paddles? Will they work with Indy 500? Now, these aren't Atari paddles. These are the paddles I built in my last Atari video, and they're not compatible with Indy 500. Atari paddles and Atari driving controllers almost look identical, with the exception of some little sticker that goes on the bottom of the game controller. If you were to try to use paddles with the Indy 500 game, it just wouldn't work at all. And that's because the Atari paddles use a potentiometer, whereas the driving controller uses a rotary encoder. We'll get more into that later. So we won't need these things, and let's get them out of the way. Now, the nice thing about the driving controller is that it's really simple to build, just like the Atari paddle. It really doesn't need that many components, and they're all very straightforward and simple to hook up with one another. So the components we're going to need are a project box to basically hold everything together. We will need a cable, of course, to hook up to the Atari 2600. This is an extension cable. It's got the female and male ends. We don't need the male end, so we'll just cut it off and use the wires to hook up to our controller. We'll need a cable gland to secure the cable to the project box, a push button switch, momentary just for the fire button on the controller. We'll need a rotary encoder. This is a quadrature encoder, which means that it encodes 4 different signals, and we'll take a look at how this works in a minute. And finally, we'll need a knob that will go on top of the rotary encoder so that we can turn it around easily when the controller is assembled. Now, unimaginatively, this is going to look a lot like my Atari paddles, and that really wasn't intentional. It just so happens that I have more of these components on hand, so I might as well use them. Some optional components to use are some spade connectors and JST XH connectors. These are going to be used to connect the wires to the ends of these terminals on the push button and on the rotary encoder. And I want to do that just in case I need to disconnect and reconnect the wire without having to desolder them if I make mistakes. And we'll need a piece of wire to make one of the connections inside of this controller, but if you don't have wire like this, you can just salvage it from the end that gets cut off the extension cable. So let's get all this stuff out of the way, and then we'll take a quick look at what makes this little device here work and how Indy 500, and specifically the driving controller, use it to make this game playable. So here is my rotary encoder. This is a PEC 16 made by Borns, and as you can tell, it looks very similar to a potentiometer. However, if I were to pick up the potentiometer and I try to spin it around, you'll notice that, as expected, there is a hard stop on either side. It won't rotate past that hard stop. The rotary encoder, on the other hand, it will just spin around and around and around as often as I want to do that. And then the main difference, of course, is that while the potentiometer measures resistance across pairs of terminals, the rotary encoder will output pulses across terminals. So in this case, for this particular model, it will be this terminal and this terminal completes a circuit for pulsing, and this terminal completes a circuit for pulsing. I've put together a small circuit to demonstrate what this thing does. Okay, now, this looks fairly complicated, but you can ignore this portion over here that I'm covering with my finger. It's basically a complicated way to bridge the buses across the opposite ends of the breadboard. And the transistors probably I could have done away with. It's just a way to get a higher current to switch across these LEDs. I read somewhere in the data sheet that the rotary encoder should only have 1 milliamp of current across its terminals. And I didn't think that would be enough current to light these things up. I probably could have done away with all of that and used just a more appropriate resistor value to light up the LEDs and drive it directly from the rotary encoder. I will show a schematic of this right now. You can take a look at that. And when you can also see that as I spin this, there's a pattern of alternating LEDs that turn on and off. And I'm turning this in the clockwise direction. And when I turn it in the other direction, you'll see it's basically the same pattern, but the LEDs illuminate in the reverse order. So I drew a small picture of what's going on inside the rotary encoder, and that will help us understand how the game uses this device to understand rotational direction. It looks something like this. Let's get back our rotary encoder over here. So for this particular model of rotary encoder, we have 3 terminals, A, B, and C. And the C is basically the common or the ground terminal that will complete the circuit as this thing rotates internally. And that circuit is completed between either A and C or B and C, and in some cases, both A, B, and C, as we'll see in a moment. Internally, we have 2 connections that are for A and B, and the C connection is across this track that can move either left and right. And it's not a continuous track. There are gaps in it that you can see here and here, which are basically not the colored areas on my diagram. So imagine what would happen if this track were moving in this direction as we rotate the encoder. So in the current state, A and B are not connected to the common at all. But as this track moves to the left, then the first thing that will happen is A will make contact with this blue box, which will complete the circuit between A and C. B is still not connected because it will be somewhere in this void. And as it continues to move, then A and B will then make connections with the common simultaneously. And as we continue to move, only B will make contact with the common. And then finally, we're back to the original state where A and B are both open with respect to common. Now, if we move the rotary encoder in the opposite direction, then the same behavior would follow, but we're going to get a different sequence of pulses depending on which makes contact with B and A first. So if we go this way, the B terminal will be the first one to make a closed circuit with the common, and similarly, then they will both be closed, and then similarly, A will only be closed, and then we're back to the original state where they are both open. Now that's why this particular rotary encoder is called a quadrature rotary encoder, because it's encoding 4 different signals while it rotates. Off, off, on, off, on, off, on. So how does Indy 500 use this information to encode a rotating car inside of its game? Well, if we encounter the B signal first, then we know that the track is moving in this direction. And so that might correspond to a clockwise rotation inside the game. Similarly, if we encountered the A signal first, then that means the rotary encoder is turning in that direction. And so we could deduce that the opposite motion is happening, and therefore it should encode a counterclockwise direction in the game. And by tracking the state of which things are turning on and off, we can map that to a rotation motion of the vehicle inside this game fairly accurately. Now, for more sophisticated uses of this device, you can track the frequency at which the A and B circuits are opening and closing, and that will give you speed and acceleration. But nothing that sophisticated is happening in Indy 500. It's just an option you have as a programmer when you use a rotary encoder. All right, it's time to start building our driving controller. So as I did when I built the paddles, I went around this box and I marked all the spots where I want to put my components. This is where the rotary encoder will go. My thumb is going to actuate a button on this side, so the push button will go right there. And the cable gland will mount to the front of the box over here, where the cable will snake its way out towards the Atari 2600. Now, just like a potentiometer, these rotary encoders have a tiny little bump on the side which will prevent them from flush mounting against any device or box that you plan to install this thing into. And the reason for this is to prevent the device from slipping around while it's not securely mounted on the box. You can imagine there being wires coming out from here, and if this thing isn't securely mounted in the box, when you rotate it, you're actually going to start rotating and twisting the wires on the inside. And if you keep doing this like so, they're going to coil around and get shorter and shorter, and then eventually they're going to snap from their opposite connections. So that's not a desirable situation, and the designers of these rotary encoders had that in mind. So what you do to solve that is you put a tiny little hole, I think it's about 1 centimeter away from the center. You can check the data sheet of your component for the exact specifications, and then this will indeed flush mount with this box because this little bump will protrude from that hole. It will be covered up by the knob that's going to go over here, and consequently it will stay in place even if you didn't secure it with the nut. So let's head down to the garage and start drilling the holes in this box. Here's the wiring schematic for the driving controller, and for this rotary encoder, I discovered through some trial and error that the A pin and B pins get connected to pins 2 and 1 respectively, and the C pin gets connected to pin 8. Push button will also be connected to pin 8 and to pin 6. Now, just like in paddles, if you were to reverse the connections on pins 1 and 2, you would discover that your controls in Indy 500 would be inverted. For instance, a counterclockwise rotation on the driving controller would turn into a clockwise rotation of the car in Indy 500. This part of the schematic had me confused for a while, but a bit of analysis showed that it's not necessary for wiring to this type of device. What this diagram is showing are each of the 4 possible codes that can be emitted by the rotary encoder, and also that certain pins are listening to only a subset of those codes. For instance, pin 2 is only listening to the 3rd and 4th positions of the A terminal, and similarly pin 1 is only listening to positions 3 and 2 of the B terminal. And if you were to draw this out on the truth table, you'll find that the Atari is ignoring the code where both of these pins are set to high. So a 1 and a 1, or high voltage and high voltage. But that's not important for the wiring. We just need to hook up pin A to pin 2 and pin B on the encoder to pin 1. And I've gone ahead and used my multimeter to figure out which of the 4 wires we need to use on this cable. I basically jammed a paperclip in each of these holes and figured out where the continuity lies to the wire for pins 1, 2, 6, and 8, and it's these 4 wires here. It's probably not going to be the same on your cable. I would test this every single time to be sure because we don't know who is making these cables. And to help me remember all that, I produced this cheat sheet so I can Refer to the color coding when I go to wire up my controller. Alright, we've reached the end of the build, so let's give this driving controller a test with Indy 500 on my Atari 2600 Junior. I've got the system hooked up to a proper video capture system, so we should see a reasonable image on the screen once this thing fires up. Let's give it a go. Huh? What is this? Why does it say Sega? Insert credit? I've never seen that in a game before. What? Do I push select to insert credits? That doesn't seem to be doing anything. What about reset? No. This is really weird. Let me give this another try. I've never seen that happen before. Maybe there's something wrong with the cartridge. Let me blow into it. Alright, maybe that will have fixed it. That was bizarre. Hey, alright. So, this is Indy 500. As you can tell, there are two cars that are going to race around the track. It's clearly a two-player game by default, but I think there's a one-player version that just counts laps. Yeah, let's pick something easy because I'm not very good at this game. Alright, how about this one? Alright, here we go. Yeah, alright. So this is working quite well. The controller is very sensitive. That's the first thing I noticed, and I think that has to do with the rotary encoder that I selected. I used a PEC 16 with a 24-position rotary encoder, and the Atari specs call for a 16-position rotary encoder, so clearly there's a lot more resolution in this thing than what was initially designed to be used. So an easy way to fix that is to change the rotary encoder. You can also use a larger knob because the amount of travel that you have to put on the rotation is greater, so it should compensate for the increased resolution. But I think you can get used to this. It's no big deal, really. Okay, let's try another game. How about this mode? This looks a little challenging. I don't want to do that. Okay, let's look at this two-player mode. I guess I'm supposed to get the target? Yep, okay. This is just to see who gets the most points by collecting these targets. One thing I like about this is that they built momentum into the game. For instance, if I take my finger off the throttle, look at that, the car starts to gradually slow down. It doesn't come to a full stop immediately. And that is fantastic for 1978. I mean, someone had the foresight to build momentum and basic dynamics into this game. That's pretty neat. Man, I really suck. Anyway, this seems to be working just fine. This is Indy 500, and this was how to build a driving controller for your Atari 2600. So that will wrap things up for this video, and as always, thank you for watching, and I hope you find this information useful. Please feel free to add your comments to the discussion below, and to use the like and dislike buttons at your leisure. Don't forget to subscribe for more content, and I hope to see you back soon.